So for the electron diagram of this one is called an adduct, okay, an adduct. That means the lone pair of N donate to boron. So of course the original molecule is here we have the ammonia. So you simply write down the electron diagram of ammonia. However, the lone pair exactly from nitrogen shared with the atom boron, so that the boron can form octet 2, 4, 6, 8 octet again. And the boron, of course, still with 3 fluorine atom, okay, to form 3 normal covalent bond here. And I make use of a cross or a triangle here because I want to distinguish the bond pair between boron and fluorine, and also the dative between the boron and nitrogen here. Okay? I mean, you need to use different electron symbol for the lone pair here and also the bond pair here. But of course, the electron will not have a different size or different shape in the actual case. But we need to use a symbol in order to distinguish from dative covalent bond and the covalent bond in boron originally. So this is the electron diagram. So how about number 3? In fact, this type of question you seldom find in DSE, but you can find in CE. And I'm sorry for students come to find me asking about this question. I let them know we need to arrange the order. I'm sorry because the question did not ask you to arrange the order. I find it in the question paper should be อาการ解釋 for the difference in melting points of these 3 compounds. So for each type of compound, you need to answer the melting point in terms of structure and bonding. So the solution should be something like this. Firstly, okay, you choose a magnesium oxide. So we have the structure first because they pack together to form a giant ionic structure. And in terms of structure. And then in terms of bonding with strong ionic bond between the ions. So high melting point, you need not to arrange the order. Okay, you simply write down high melting point is enough. And when I mark your papers, I find that still some of you have misconception. They write down between the molecules with strong ionic bond. This one totally wrong. Because for ionic bond should be the electrostatic attraction between oppositely charged ions. Only ions can have ionic bond. Okay? So please bear in mind. And for the second part, how about silicon dioxide? It has giant covalent structure, again in terms of structure. Why? Because they have strong bonding between silicon and oxygen atoms, again atoms here. Okay? And I find that some of you still use molecule between silicon and oxygen molecules, okay, will have a strong covalent bond again. Must be wrong. In order to have covalent bond, we should have sharing electrons between atoms only. Atoms. And then for sulfur trioxide, it has a simple molecular structure. Again, I can't in terms of structure. Simple molecular structure. And only weak van der Waals forces, or you may use intermolecular force, okay, very weak. So no melting point here. Okay? So you account these 3 compounds, the melting point, according to the structure and bonding here. Okay? And one more thing, some of you still don't know how to distinguish between silicon dioxide and sulfur trioxide. You may say, they are all covalent compounds? Yes. However, in our level, we simply remember silicon dioxide, graphite, and diamond. They are the three substances that have giant covalent structure. The other covalent compounds, actually, most of them are simple molecular structure. Okay, so I stop here first. It's about the reduction, extraction of metal. So this one, please. Why we have this formula, copper 1 oxide, what that means? Now I use cross method for you. Copper 1, that means 1 plus charge, but normally it should be 2 plus. But now it's 1 plus. And then for oxide should be 2 minus because it is group 6, and I mentioned it before. And we use cross method here. So the formula for copper 1 oxide should be Cu2O. Okay? And we are with hydrogen and form metal and water. And this one should have 2 here. Balance equation. And then ask you about the observation. This one, copper oxide, is black in color. And form copper should be brown, reddish brown in color. Not so difficult. You should know it. And then why? We need to burn out the hydrogen because the hydrogen is explosive or flammable. If it accumulates in the tube inside, it will explode under high temperature. So we try to burn it out in order to remove the hydrogen. Okay, prevent explosion. Okay, so part D. Calculate the mass of copper form. How to calculate? Again, this is 4-step method, right? 4-step method. As I mentioned before, when we use which method for calculation, now I explain it in Cantonese again. You need to remember. So at step 1, you find that here. For part A, you already know the first step, balance chemical equation. The second step, you try to find out the mole of copper oxide first, because give the mass to you, the mass, and then divided by the molar mass of copper oxide. I think this solution, okay, because it is not done by me, I put 2 times here. I just eliminate this one first. I just want to find out the number of mole of copper oxide first. Should be mass divided the molar mass. So we have the mole of copper 1 oxide. And then the first step you need to find out should be 1 to 2 ratio. This one we know the number of mole, and we try to find out the mole of copper because we want to find out the mass of copper form. So I will put the third step here. That means mole of copper 1 oxide to copper should be 1 to 2 equals to 1 to 2. So the last step, we will have mole of copper form will be 2 times this value. This value is the mole of copper 1 oxide. And then we can find out the mole equals 0.0726. And then we can have the mass. How to find out the mass? Times the atomic mass of copper. So you find that for this type of question, only 2 marks is correct. Because 1 mark for your method and 1 mark for your answer. And I find some of you did not write down the unit for the answer. So, you know, I'm not a good teacher. I will deduct whole mark if you don't have units. However, if you go to public exam, if the marking is not tight at that year, the markers will give you mark even you don't have the units. However, if the marking is very tight, units, you miss the units, okay, will deduct marks. Maybe 0.5 or maybe whole mark. Okay, you get my point?